This is problem number 9 from section 9.6. In this problem they say, for the given linear system, complete parts A and B. Part A, write the system in the form AX equal B. Part B, solve the system by finding A inverse and using X equals A inverse B. All right, let's start by writing this in the form AX equal B. Remember, A is the coefficient matrix. So A is the coefficients of each of these equations. So I'm going to write that as a 3 by 3. That's 1, 0, 1. 3, 1, 4, negative 1, 1, 1. That's A. X, don't get confused with little x, is the variable matrix. I have 3 variables, x, y, and z. So I'm going to write this as x, y, z. And then B is the constant matrix, negative 11, negative 34, negative 5. And they want us to write this in the form AX equal B, so we're going to say AX equal B. So this matrix, 1, 0, 1, 3, 1, 4, negative 1, 1, 1, times the x, which are the variables, x, y, z, equal the b part, which is negative 11, negative 34, negative 5. So that's part A, complete. Part B, they want us to find A inverse and then use X equal A inverse B. So for part B, we're going to need some room here. So I'm going to rewrite this A matrix on another blank sheet. So we're going to use and we're going to say that we have A inverse is going to equal 1, 0, 1, 3, 1, 4, negative 1, 1, 1. Set it basically equal to the identity, remember? And we're going to use Gauss-Jordan elimination to actually solve this. So Gauss-Jordan to find A inverse. Okay, here we go. We need to cancel out this one to be 0, but we also need to cancel this one to be 0 as well. So I'm going to multiply the top equation by let's multiply this top equation by negative 3, R1, and we're going to multiply the bottom equation by, I think we're going to multiply that one by negative 3, R3. And as we do this, we're going to get negative 3, 0, negative 3, negative 3, 0, 0. The middle equation stays the same. And then the bottom equation is going to be 3, negative 3, negative 3, 0, 0, negative 3. And now we're going to take and we're going to say, we're going to do R1 plus R2 equals R2. And then we're going to do R1 plus R3 equals R3. And then at the very end, we're actually going to do negative 1/3 R1, just to put it back to its normal state. Let's start by doing R1 and R2. So this gives you 0. This will give you a 1. This gives you a 1. This is negative 3. This is 1. And this is 0. And then I get 0 down here, -3, -6, and -3, 0, -3. We can do the 0 and the -3. On top then, I'm going to go through and multiply by -1/3 again. So that's going to be 1, 0, 1, 1, 0, 0. All right. Now I just need to cancel this bottom piece to 0. So I'm going to multiply by 3R2. Actually, you know what? I'm going to multiply, instead of doing that, I'm going to do 1/3 R3 to get there, because that'll bring it down to be one less step. So we're going to get 0, 1, 2. This should be -1 and -2. This is -1, 0, -1. Everything else stays the same. 0, 1, 1, -3, 1, 0, and 1, 0, 1, 1, 0, 0. All right. Now we're going to add row 2 with row 3. That's going to equal row 3. So as we do that, we get 0, 0, when we do 1 and -1, -1, -4, 1, -1. All other things stay the same. 0, 1, 1, -3, 1, 0, and then 1, 0, 1, 1, 0, 0. All we have to do is cancel both of these to 0 now, so I can add row 3 with each of those to do that. So row 3 plus row 1 is going to equal row 1. Row 3 also with row 2 is going to equal row 2. So let's start with the row 1. I'm going to get 1, 0, -1 and 1, 0, -4 and 1, -3, 1 and 0 is 1, -1 and 0 is -1. Now I'm going to go to row 2. -1, well, first of all, 0, 1, and then -1 and 1 is 0. -4 and -3 is -7. 1 and 1 is 2. -1 and 0 is -1. And finally, I'm actually going to, at the very end, I'm going to take -1 times the bottom row. -1 times R3. That way, then this is all set up nicely. So I get 0, 0, 1, 4, -1, 1. So A inverse is -3, 1, -1, -7, 2, -1, and 4, -1, 1. So what they want us to do now is they want us to use x equals A inverse B. Now we're going to have to bring back in what B and X were. Remember, X is the variable matrices, and B is -11, -34, -5 from our constants. So we're going to give ourselves a little room here. Let's write down the equations that we have so far. We know x is x, y, z. We already have A inverse, and we know B is -11, -34, -5. So when we do x equals A inverse B, we're going to say x, y, z is equal to -3, 1, -1, -7, 2, -1, 4, -1, 1, times b, which we know b to be -11, -34, -5. So that means when I come down here, I'm going to say x, y, z is going to equal this multiplication. This is a 3 by 3 and a 3 by 1, meaning we're going to get a 3 by 1, right? Look at the outsides for our answer. So we're going to end up with a 3 by 1 here. Now, I'm going to go through in the calculator and do most of this work for the multiplying. We're going to start here, and we're going to take -3 times -11 plus 1 times -34 plus -1 times -5. That gives you 4 for an answer for x. Now we're going to do -7 times -11 plus 2 times -34, 2 times -34, and then plus -1 times -34, 43 for your y value. And finally, we're going to take 4 times -11 I'm going to move this over here so it's a little bit better than that. So 4 times -11 plus -1 times -34 plus 1 times -5. And you get -15 here. So our solutions are going to be 4, 43, and -15. I just want to double check, make sure I multiplied right here. I made a mistake right here. If you guys notice that line right there, I took this line times -34 twice. So this 43 is actually incorrect. I'm going to go ahead and fix that. So we're going to just cross this out lightly. This is 4 here. This is -15. This number, though, I'm going to take that line. That should have not been -34. I did -7 times -11. I did 2 times -34. Yep, 2 times -34. And then I was supposed to do -1 times -5, and I did -1 times -34. So let's delete out that and put 5 there. And I got 14. So my x value is 4. My y value is 14. And my z value is -15. And how did we get these solutions? Well, we went through and we used, at the very beginning, we used A to find A inverse, and then we used this x equals A inverse B to solve it out.